Hello and welcome to ATG 4950. This is a continuation for Chapter 1, Part 2. We are going to address the survey design and analysis, continue with that. And in this part, we will continue with the analysis part. We ended the part 1 saying that we have qualitative and quantitative data, and we said that the quantitative data is numeric numbers. So for the numbers, we are going to start analyzing them. Even for the qualitative data, it has text analyzer or certain software packages to analyze, but we will concentrate in this session on the analysis of the numeric or quantitative data. So again, we collected the data. We have qualitative, we have quantitative. We have lots of data. What are we going to do with the collected data? We need to prepare it. And like we said, the first step of the analysis is the data preparation. What do we mean by data preparation? Means logging the data in. If it's in paper, written on paper, and we need to log it into the system or enter it into the system, then we need to log in the data or enter it, and to make sure that it's not redundant, to make sure of the accuracy of the data, the transformation of the data. If we have missing data, what do we need to do with it? And of course, developing the proper database structure for it. So for logging in the data, the data collected from survey can be in different forms and at different times. So every time we collect data, it can be logged in as received if it's automatic, or it can be logged in based on the paperwork and the people that's working on entering the data or logging in the data to the system. Some data could be collected through a computerized system, and another data could be collected through paper work, which is the old way on collecting information. And that, of course, depends on the technical literacy of the population to be surveyed. If they have the ability or they have the knowledge on how to use computers, then they can use the computerized system. If not, then we have to use the old way of pencil and paper. The received data should be checked for accuracy, and the data should be checked for readability and completeness. Some of the numbers might be entered based, especially if we are dealing with pencil and paper, and one wrote a number 3 that shows as an 8, and the data entry person entered it as an 8, so we have a wrong number. That's why we have to check for readability, especially with the pencil and paper or pen and paper surveys. Then we can also, to make sure of the accuracy, we can ask reversal questions that can be used to ensure the accuracy. You ask a question, would you like fishing? And then you can say in another question, do you hate fishing? So you can, from the reversal questions, you can ensure that the answer was the same in both questions. And that's been done a lot now, even with range or rating, where we have you have to rank or rate from 1 to 5. So sometimes they will give you a question that you can rank or rate as 1, which will be the same as ranking another question as 5. It's reversal, or the opposite of the question. For data transformation, we need to deal with the missing data and anomalies and see why do we have that missing data. Can we fill it? How can we fill it? Some software packages will treat it as blank values or as missing values, so it will put a null value in that place. Some other packages will use a 0. Other packages will allow you to use the average or the median or the mode of the collected information to replace the missing data. But again, all that depends on the type of information that you are collecting. If it's sensitive information, you cannot replace the missing data with zeros or with the average, because that might skew the data to give different results. And you would like the data that you are dealing with to be as accurate as possible. Data can be also categorized to increase efficiency and actually to make it easy to access when you are analyzing the data. One of the steps to analyze the data is to develop a database structure, and the database structure is the way in which you intend to store your data for easy manipulation, query, and analysis. If you have it in an easy way, stored in an easy way, then you can just import the data or export it somewhere for a software package to analyze it and return the results back. Database can be managed using database management systems such as Oracle or SQL Server or DB2 or even Access database. The purpose of that is to increase the flexibility of manipulation, and again to make it easy for you to get to the proper data in the proper time, analyze it, and return the results. Once we have the data, we start analyzing it. To start that, we describe the data. So to describe the basic features of the data in the study or in place of study, we use descriptive statistics. It provides simple summaries about the sample and the measures. The summaries with simple graphic analysis, form the basis of virtually every quantitative analysis of the data. You can see what does the data represent and what does it show exactly. That's the basic of, or that's the importance of descriptive statistics. What do we mean by descriptive statistics, or what's this? How can we calculate it, or how can we get it? Descriptive statistics is the one that you used to perform when you were in middle school and high school, and after that, which is just finding the mean, median, the mode for the collected data. And we know that the mean is the arithmetic average, the median is the value in the middle, and the mode is the value observed the most in the data. Each of these measures is legitimately referred to as an average. They call it an average, but actually the average is the arithmetic mean. So for a sample, if we took a sample from the population, the mean will equal to the addition or the summation of the values of the sample divided by the number of points in that sample. For the population, the mean will equal to the summation of the whole values in the population divided by the number of the population. For example, if we have the following ages, which is for 7 employees in a small company, 53, 32, 61, 57, 39, 44, and 57. Calculate the population mean. Because I have, this is the population, I didn't take sample of the population. I have total of 7 employees in that company. So the whole population for that company is 7. That's why I'm calculating the population mean, which will equal to the addition of all these values, all these points, divided by the 7 employees. So it's 343 divided by 7. That means the average age in that company is 49 years. To calculate the median, actually, if we have values such as x1, x2, xn, we have to order the values so that they will be in order from the smallest to the largest, or to the most, and the mean, or the median will equal to that value that's in the middle. That value in the middle, if n is odd, but if n is even, then it will be the two values in the middle divided by 2. The two values in the middle divided by 2. For example, the following are ages of all 7 employees of a small company. Since I have 7, then that's an odd number. Calculate the population median. The solution to find the median, first we sort the data. So we have 32, 39, 44, 53, 57, 57, and 61. We arrange them from smallest to the largest, and based on that we got 53 as the median, which is the number in the middle. If you can see here, we have 3 numbers before and 3 numbers after. If the previous in the previous example, if it has an extra person, and now they have 8 employees, if they have 8 employees, before that, if we have 8 employees, then what we do, we calculate, we take the median as the 2 numbers in the middle divided by 2. So if we have an extra employee, we have 8 employees, then we take the 4th and 5th employee ages, add them, divide by 2, and that will be the median at that point. For the mode is the most frequency, or the most data point that's occurring. In this case, I have 57 that occurred twice. That's why the mode is 57. Yeah, that's when I have 8. So we need the mean, the median, and the mode for this one, and I added another person here. If we do that, then we can calculate, and you can find the values. Actually, I will leave this example for you to calculate. It's an easy example. Just find the mean, the median, and the mode for that one. Which is the right average? Like I said before, usually we take the arithmetic mean as the average. The median are useful when extreme values, high or low values, would have a pronounced effect on the mean. The modes are used frequently for quantitative data, they are often a good descriptive measure of qualitative data, but not in quantitative. So the modes are used infrequently. They are not used that much in quantitative data. You will see that the data will vary. So we will have a number in the middle, and there is a variation of numbers on both sides. Especially if we have bigger range of data, the variability will be more. So we need to study what's called variance and standard deviation and the coefficient of variation. So what's the range? The range is the difference between the largest and the smallest values. So r is equal to xn minus x1. The variance is the mean of the squared differences between the observations and their mean. And this is the equation on how to find the variance. And I'm sure that you took that in a different class or before, and you know all these values. You took it in maybe high school or even middle school for some people. For calculation of the sample variance, also we can use another equation, and sometimes this is more efficient than the previous one, but any of these equations will work. So whether this one or the one in the previous slide, both of them works fine. The standard deviation is the square root of the variance, expressed in the same units as the mean. So both are the same. So the standard deviation is the square root of the variance, square root of the variance. To calculate the coefficient of variation, we divide the standard deviation by the mean. And that's a relative variation. It's a measure for a relative variation. You can look at the example of finding the range. And this is closing prices for a certain stock in 5 successive days or successive Fridays. And based on that, we are going to find the range, the deviation of each price, the variance, the standard deviation, and the coefficient of variation. So try and work on the example. Again, it's an easy example, straightforward, just a practice for you to study and know how it's being calculated. How much accuracy the measures. The statistical measures cannot be more accurate than the data themselves, because we are getting those measures from the data. That's why the main suggestion is to go back to the accuracy step in collecting the data at the beginning, and make sure if you need additional digits, you can add additional digits after the decimal to make sure that it's more accurate. So the more significant digits you have, the more accuracy you have. The whole statistical issue and descriptive statistics, we use that just to know exactly what type of data I'm dealing with. Once I know that, then I have to infer about the data. And the inferential statistics is the investigation question that I need to use to hypothesize about the data and state my assumptions or state my hypothesis. Um, in many cases, the conclusions from inferential statistics extend beyond the immediate data alone. For instance, we use inferential statistics to try to infer from the sample data what the population thinks. What do they think about the product? What do they think about the features? All these kind of information can be collected or can be inferred from the inferential statistics or the extension of the investigation that I will do using my questions and my hypothesis. Or we can use the inferential statistics to make judgments of the probability that an observed difference between groups is dependable one or one that might have happened by chance in this study. So if, for example, I saw that many people are interested in the product that I'm developing, then I know that maybe the sales, I will infer that the sales, or I will judge that the sales will increase or will be high. So the probability of selling this item is maybe 80% or 90% as a startup, which is a very good percentage if you think about it. Basically, we use inferential statistics to make inferences, descriptive statistics, inferences from our data to more general conditions, while we use descriptive statistics simply to describe what's going on in our data. Again, this we learned this as part of the gathering the survey, gathering the information. If we have numeric or quantitative data, then we have to analyze it, study it, and put our assumptions, put our investigation questions, and based on our investigation questions, we can infer what will be or what will happen and what kind of features do I need to my product. So far, we are in the phase of developing the product, finalizing it, then collecting data to ensure that all features in that product is being encountered or being captured. Once I have the product developed, I will start the testing and evaluation for my product. Now, since we captured those information, we captured what kind of features are needed through quantitative or qualitative questionnaires or interviews. Let's take these features and go to the product development. So the second chapter will be about taking these features and developing the product development. That will be all for this session. Thank you and have a great day.